Good day, everyone. Welcome to another discussion of business statistics. Our topic is organizing categorical data. So we'll be applying concepts of organizing categorical data. In today's discussion, there will be five examples that we'll be dealing with. So first item is the problem. The Transportation Security Administration reported that from January 1st, 2008 to February 18, 2009, more than 14,000 banned items were collected at Palm Beach International Airport. So the categories were as follows. There are five categories here presented in table form. First one is flammables or irritants with a frequency, knives and blades with this frequency, prohibited tools with this frequency, sharp objects with this frequency, and others with this frequency. Okay, so these are already tallied the item presented in tabular form, so the frequencies are already added up. So first question, compute the percentage of values in each category. So this is very simple. We just simply get the total of all the frequency. So that's under Microsoft Excel or a spreadsheet. Press equal sign and then click sum on our function argument. Then select all the cells involving the frequency. Press OK. So our total should be 14,091. Okay. You can also copy the formula so that it automatically computes the percentage or the total percentage under this different categories. So the percentage for the first category, to compute it, just press equal sign, then this will be our numerator divided by our total. So that's // total. So that's C9 8,350 divided by C14, cell C14, that's 14,091. Press equal sign. Okay, so notice it's already on percent form, but sometimes this could be under this decimal value 0.05925,768. Now to convert this to percentage, you simply press the icon percentage and you'll get 59%. Similarly with the total, you can also convert this to percentage sign or value, or simply click this percent sign. Okay, so it's rounded up to whole number. Now to copy the formula, make sure that we lock our denominator or our divisor, okay, so that when we drag the formula, the cells will not move for the divisor or the denominator, which is 14,091. So going back to this, notice the change of my cursor. It's ready. When it becomes a small black cross, then drag it down. So automatically our total is 100%, signifying that our computation is correct. So, because the total of this should be 100%. So flammables, that's 59%, knives and blades, that's 29%, prohibited tools is 5%, sharp objects 4%, the others is 3%. So we are done with letter A. Letter B, what conclusions can you reach concerning the banned items? So notice that all these three, okay, are all tools. Knives and blades are tools, prohibited tools, and sharp objects are all tools. So on my conclusion, I would combine them as one together with the others. So almost 60% are flammables or irritants pertaining to this category. That's around or almost 60%, and the rest should add up or sum up to 40%. So, and around 40% are prohibited tools, that's with S, and objects, and you can also include in others. Okay, so I'm done with my conclusion. So I'm done with item number 1. Second item. Okay, item number 2. Okay, so um, let's look at the problem. Federal obligations for benefit programs and the national debt were $63.8 trillion in 2008. We are talking about the federal obligations of the United States of America. So the cost per household for various categories was as follows. Okay, so I have here 1, 2, 3, 4, 5, 6 category. So notice that this category under blue color or filled cell with color blue are all pertaining to retirement stage. Okay, so civil servant retirement, that's 15,000 or more than 15,000 US dollars. Federal debt, 54 or more than 54,000 US dollars. Medicare, that's 284 or more than $284,000. Military retirement is more than 29,000 or almost 30,000 US dollars, and then Social Security is under 160,216 US dollars. The others, that's 2,172. Okay, so this is the data being projected. So notice that all these three are considered to be on the category of retirement. That's why I highlighted them in that color. So in my conclusion later on, I could actually combine them as one. Then if we talk about Medicare, these are the health insurance benefits by an employee in the US. Okay, so first question, compute the percentage of values in each category. So we do the same process, press equal sign, then we add all these values. So we click sum. Okay, that's sum under our function, then select all the cells involving the frequency of the cost per household. Press enter, and we should have 546,758 in US dollars. To get the percentage, we start with the first category, so we press equal sign. This would be our numerator divided by our denominator. Press enter, and you have 2.9%. It's I actually set it up for percentage value, but normally if that's not set up yet, you'll see a value of 0.0289909. So what you need to do is just to press the percent icon, and you will have 3%. Or let me add 2 decimal place. That would be 2.9%. Okay, so if I want to copy this formula, I need to lock the denominator. So all my denominator or divisor should be this cell C14, 546,758. Okay, if I drag this down, the values are there. That's the percentage. And also if I copy this, that's percent, you'll have a total of 100%. So this should add up to 100%. Otherwise, something is wrong with the percentages. Okay. So next question: what conclusion can you reach concerning the benefit programs? Okay, so we now go to our conclusion or interpretation. Again, let's talk about Medicare. Medicare is a national health insurance program, and security or social security is a term used for old age, survivors, and disability insurance program. Okay, so I'm gonna I'm gonna combine these three in my conclusion because they are all pertaining to retirement programs, okay, in even social security. All right, so Medicare is more than half or more than 50%. Then social security, retirement or military retirement and civil servant retirement should be around 30, 38, or let's see, around 40. Yes, that's right. So in my conclusion, more than half or more than 50% of the costs were related to Medicare, and around 40% of the costs are related to retirement plan. These are all retirement plan. So roughly these three is around 40%. And we have 50, 40, the remaining 10% would be of federal debt. Okay, so we have federal debt and others, that's the remaining 10%. Okay, so we could have that as our conclusion. Next, number 3. The Energy Information Administration reported the following sources of electricity in the US in 2008. So we have here the table. This is our data. Okay, so we have sources of electricity: coal, hydro, electric, natural gas, nuclear, and others. Now, letter A, compute the percentage of each category, okay, or the percentage of values. So, similar procedure: press equal sign, look for sum, select the cell, then press enter. So our total is 4,110.3 millions of megawatt hours. Percentage, the same process like the previous two items. Press equal sign, then press C9 for our numerator, divided by our denominator, that's the total of the frequencies, then press enter. So again, in decimal that would be 0.485221, but in percent, okay, that will appear as 48.52%, but I can round it up to whole number. Okay, now if I want to drag the formula to lock our denominator, I'll place a dollar sign, then drag it down. Similarly, the total should be 100%. Okay, so it shows in our table that the highest is 49% on coal. That's around 50%. Hydroelectric is 6%. Natural gas is more than 20%, or 21% to be exact. Nuclear is 20%, and the others are 4%. So letter B, what conclusions can you reach concerning the sources of electricity in the United States? So the conclusion: almost 50% of the source of electricity is from coal. So I rounded up to 49 out of 50. That's almost 50%. Okay. Around 20% is from natural gas, and almost 20% is from nuclear plant. So this is around 29 or 20%. That's natural gas, and almost 20% is from nuclear plant. I say almost because in decimal 19.621 to be exact, that's almost 20%. I just rounded up to whole number. Okay, so that's 50, 20, 20. The remaining 10% is from hydroelectric and others. Okay, I could have that as my conclusion. On your answers, you can have similar conclusions, as long as you would be able to sum it up. Okay, so we're done with the third item. Now we go to the fourth item. Just clear that color. Okay, so here's a more interesting problem set. So a sample of 500 shoppers was selected in a large metropolitan area to determine various information concerning consumer behavior. Among the questions asked was, do you enjoy shopping for clothing? The results are summarized in the table, or in the following table. So this is the table. Okay, so there are 500 respondents or shoppers, and they were asked if they enjoy shopping for clothing. Okay, so this is your data. Now for yes, there are a total of 360. For no, a total of 140. For male respondents, there are a total of 240. For female respondent, there's a total of 260. So respondents according to gender are almost equal. It's just a difference of a few percent or a few number. Letter A, construct contingency table based on total percentages, row percentages, and column percentages. So we have the first contingency table. This is total percentages. So how do we arrive to 27%? It's simple. So from our data or our original table, we simply get the quotient of the frequency on this cell divided by the total, multiplied to 100% or converted to percent. So 136 divided by 500, that's 27%. To do that on Excel, let me just clear this. So that's equals, press your numerator 136 divided by your denominator 500, press enter, and you have 27%. Now you don't need to redo that on all the table, just simply copy this formula, but make sure that your denominator or the divisor 500 is locked up. Okay, so you can simply copy on all cell. Okay, so in our total percentages, there are 72% who said yes, they enjoy shopping, and 28% said no, they don't enjoy shopping for clothing. And for gender, there are a total of 48% male respondent and a total of 52% female respondent. So we are done with total percentages. Next, row percentages. We'll be talking about the rows. Okay. So particularly, how many said yes and how many said no. Okay. I have here my values. How did I arrive to these values? Notice my formula. It's C11 divided by E11. So if I go back to this table, C11 is located here and E11 is located here. So meaning I divide, or I took the quotient of 136 and 360, then convert it to percent. Okay, so just to show you, that's equals, then go to your original table, that's your numerator, divide by your denominator, then press enter. Okay, to copy the formula, make sure that your denominator is locked, then drag the formula. So there you go. The number of respondents who said yes under male, that's 38%, and for female, that's 62%. So meaning in every 100 male shoppers, 38 of them enjoys shopping for clothing. Similarly, for every 100 female shoppers, 62% of them enjoys shopping for clothing. Okay, we now go for the no, who doesn't enjoy shopping for clothing. Press equal sign. That is 104 divided by 140. Then before we copy the formula, lock our denominator or our divisor, then drag the formula. So to interpret this, out of 100 male shoppers, 74 of them doesn't enjoy shopping for clothing. And for females, out of 100 female shoppers, 26 of them doesn't enjoy shopping for clothing. So that's how you interpret this result under row percentages. Next would be column percentages. For column, we'll be talking about gender, the male and female. Okay. So to do this, similar, let me just show you. That's C11 divided by C13. Okay, so that's 136 divided by 240. Then convert it to percent. So in my result, that's 57%. Okay, and then drag the formula. You'll have 43 for no and a total of 100%. You do it the same with the female column. Okay, so to interpret this, out of 100 male shoppers, 57 of them enjoy shopping for clothing, and 43 of them does not enjoy shopping for clothing. For female, out of 100 shoppers, 86 of them enjoys shopping for clothing, and 14% or 14 of them doesn't enjoy shopping for clothing. Okay, so we are done with our first question. We were able to construct contingency tables for total percentages, row percentages, and column percentages. Now we go to the analysis or the conclusion. Okay, so let's talk about business here. If you're a businessman, what can you infer, or what decision or conclusion can you take from this presented table? So first, well, this is my conclusion. Out of the 500 shoppers, almost 75% or 3 out of 4 shoppers enjoy shopping for clothing. So where did I took this information? Let me go to this. Okay, so from this interpretation, that for every 100 shoppers, 72% or 72 out of 100 will agree that they enjoy shopping for clothing. So this is almost 75%, and 75% is 3/4. So going back to my first statement, 3 out of 4 shoppers enjoy shopping. So for every 4 shopper who enters a shopping mall, 3 of them would love to go shopping for clothing. That's what notice in every shopping mall, most of the business establishments are clothing lines, because due to these statistics, most of the customers, or 3 out of 4 customers who enters a shopping mall, would go buy or would go shop for clothing. Okay. Another conclusion, 86% or around 9 out of 10 female shopper enjoy shopping for clothing. Where did I took this conclusion? From this table. Okay. So 86 out of 100 shoppers, or this is roughly 9 out of 10 or 90 out of 100. Okay, simplified, 9 out of 10 shoppers or female shoppers, I'm talking about the gender, enjoy shopping for clothing. So for every 10 female shopper who enter a shopping mall, 9 of them would love to go shopping for clothing. Similarly for male, okay, for every 10 male shopper, who enters a shopping mall, 6 of them would enjoy shopping for clothing. So that's a big number for our shopping statistics. So business establishments, or mostly shopping mall, would have business establishments like clothing lines, because this is where customers would mostly go. Next conclusion: female enjoys shopping for clothing more than male by 20%. What did I infer? Took my inference. So this one, comparison between male and female. So this is almost 40%, and this is around 60%. The difference is 20%. So all those shoppers, or all those customers who love shopping for clothing, it seems that female enjoys shopping by more than 20% than male. So this is where I took my conclusion. Okay, and male does not enjoy shopping for clothing more than female by 50%. So if I go back to my row percentages, the difference of these two is around 50%. It shows that all those who does not enjoy shopping for clothing, it seems that male does not enjoy shopping for clothing for more than 50% than female. So this is 26%, or this is around 25%. This is around 75%. So the big difference is 50%. Okay, so that's item number 4. Now we go to our last item. Each day at a large hospital, several hundred laboratory tests are performed. The rate at which these tests are done improperly and therefore need to be redone seems steady at about 4%. In an effort to get the root cause of these non-conformances, tests that need to be redone, the director of the laboratory decided to keep records over a period of 1 week. The lab tests were subdivided by the shift of workers who performed the lab test. The results are as follows. So the director would like to know the root cause of these non-conformances. Okay, meaning they have to redo the test because it's done improperly. So this is the result after a week. So on a day shift, the total lab tests is 670, and those that needs to be redone, that's 16. On an evening shift, the total lab test for a week is 330, and the test that needs to be redone is 24. Okay, so by total, all tests that needs to be done is 40, and all correct lab tests is 960. Total is 1000. So first question: construct a contingency table based on the total percentages, row percentages, and column percentages. So we have the contingency table below. So this is our solution. So to get this, similar with item number 4, we simply divide 16 by 1000 and we change it to percent. The same with the rest of these values. Okay, so let me just show you. Let me delete these values for you, and then press equal sign. That's 16. We are talking about the column day and the row non-confirming. So this one, column day and then row non-confirming. So that's C14. Value is 16 divided by our total, which is 1000. Press enter. That's 2%. I round it off to whole number. Okay. Then if this is not yet converted to percent, you will see a value of 0.016. But since I converted it and rounded it off, you'll see a 2%. Now, before copying the formula, make sure that you lock the divisor, which is 1000. Then drag it. You can now drag it to another cell. Okay. Let me redo that. There you go. So you will see the total non-confirming lab test is 4%, as it was mentioned here. It seems steady at about 4%. And still, we are looking for the root cause of these non-conformances. So we go to our row percentages. Okay, so we're talking about confirming or non-confirming and confirming. So to do this, okay, we simply divide 16 by 40. Okay, that's C14 divided by E14. Similarly, that's 24 divided by 40. That would be our divisor. Okay. So to show you, let me delete that. That's equals. Then we go to our original table. That's C14 divided by E14. Press equal sign. That's 40%. Originally, that would be 0.04. Then we press that symbol percent convert to percentage. Then drag the formula. Okay, you'll notice a problem on our formula because the divisor was not locked up. Okay, so if I redo it, there you go. Similarly, for this confirming, that's equal sign and go back to our original table. That's 654 divided by, that's / 960. Press equal sign, and that's 68%, already converted to percent. But in decimal value, that would be 0.681. So just press percentage sign and you'll be able to convert this to percent. And before you drag the formula, make sure you lock the divisor. There you go. So to interpret this, okay, it seems that those non-conforming lab tests, okay, 60% of it are happening during the evening shift, and 40% are happening in the day shift. Okay, so for those confirming lab tests, 68% of this are happening during the day shift, and small 32% happens on evening shift. Okay, so not it's not that hard to interpret if it's a row percentage. Now we go to our column percentage or column percentages. So I have here 2% non-conforming during the day and 7% non-conforming on the evening. How did I get this? Okay. Again, going back to our original table, so you simply divide 16 divided by 670 and you'll have your percentage. Similarly, for non-confirming, divide 674 by 670. So just simply click the cells. So to do that, let me just show you. So that's press equal sign. Then we have 16 divided by the divisor 670, 2%. And for our non-confirming evening shift, press equal sign. Then we have 24 divided by our divisor 330, press equals. Okay, so I can lock this up before copying the formula. Similarly with this result, I can lock the divisor, and then I can simply highlight the 2 column or the 2 cell and copy the formula. There you go. So I am now showing that on my column percentages, a big amount of non-conforming lab tests is showing during the evening shift. That's 70%, and only 2% during the day. And for confirming laboratory tests, 98% are happening during the day, and 93% are happening during the evening. Okay, so the next question, that's letter B. Which type of percentages, row, column, or total, do you think is the most informative of this data? In my understanding, this would be the most informative data because it actually shows the actual percentages of lab tests that needs to be redone or confirming. So I'm talking about this 7%. To interpret this, in every 100 laboratory tests, 7 lab tests needs to be redone because the procedures are non-confirming. Okay, and in every 100 laboratory tests during day shift, only 2 of them needs to be redone. So again, going back to the problem, we are looking for the root cause of non-conformances. So this is an effort to determine where is the root cause. So it seems that during night shift, okay, the big number of lab tests that needs to be redone is happening on this shift, evening shift. That's 7%. Okay, and only a small percentages during the day. Although in total, it's 4%. But due to our contingency tables, we were able to pinpoint that this 2% non-conforming during the day and evening is actually different if we have a contingency table under this column percentages. Okay. Again, the interpretation for every 100 laboratory tests, 7 needs to be redone during this evening shift. And for day shift, every 100 lab tests, only 2 needs to be done. So the root cause is actually during the evening shift. Okay. So conclusion: 4% of the total lab tests are done improperly and needs to be redone. Okay. So in total, for every 100 laboratory tests, there are 4 lab tests that needs to be redone. Those are the non-confirming lab tests. There are 7% lab tests performed during evening shift which are done improperly. So we were able to determine that during evening, 7 out of 100 are the tests that needs to be redone. Okay, so the director needs to do something during the night shift, maybe to enhance the monitoring for every procedures of laboratory tests, to lessen down the errors or the redoing of the laboratory tests. Another important conclusion: there are 2% lab tests performed during the day shift which are done improperly. So this is a very minimal percentage of the non-conforming lab tests during day shift. There is 20% more non-conforming lab tests during the evening shift. So it also shows that there is a higher value of 20% test that needs to be redone during the evening shift. So again, these two are the most important conclusion of this problem set, because this will actually help the director to make proper decision. Then last conclusion: there is 36% more conforming lab tests during day shift. So it also shows that during day shift, the correct lab test procedures or conforming lab tests is higher by 36% during day shift. Okay, so on your answers or on your conclusion, we may consider other conclusion or other interpretation, but most of it would actually be like this conclusion. Okay, so we are done with the 5 items of applying the concepts of organizing categorical data. Again, this is a topic under business statistics, wherein we are using statistics to make better decisions in business. Thank you for watching.